In the center of New York City, a bold new vision for the urban landscape emerges. 22,680 tons of steel, over 8,000 panels of crystalline glass. It's one man's towering dream becoming reality. One Bryant Park is said to be one of the most environmentally friendly skyscrapers in the world. With global temperatures rising, one green superstructure may alter the way we build our future. It's 8 a.m. in the center of Manhattan. And these men are on a mission. Today, they must raise over 45 tons of steel, 220 meters in the air, to complete the 48th floor of this monumental tower. They're in a race to get this skyscraper to its full height.
All right, Frankie, everything looks good, bud. Going up.
When complete, One Bryant Park will tower 365 meters above Manhattan's streets, second only to the Empire State Building as the tallest skyscraper in New York City. To do that, they must build the structure 288 meters high and then top it off with a 78-meter spire, one of the largest spires ever erected in the city. But the building's biggest achievement will not be its height. One Bryant Park is said to be one of the greenest skyscrapers in the world. Its combined green features will be unprecedented. It's an ambitious plan to have so many energy-saving systems combined into one skyscraper. And it's the brainchild of this man. Architect Richard Cook's dream is to raise the most environmentally friendly skyscraper in the world.
As an architect, I think we must immediately radically change the way we build buildings and radically change the way we build cities. I hope that when people look at One Bryant Park, they think that it could be an icon of when we started thinking fundamentally differently about the environmental impact of a skyscraper.
Cook's vision, One Bryant Park, is out to tackle a big problem. Buildings account for nearly 40% of total U.S. energy consumption. Each of these buildings need energy for lights, elevators, phones, computers, faxes, air conditioners, and running water round the clock. It's a problem that the Bank of America and the Durst Organization were ready to confront when they commissioned the revolutionary building.
We want to be seen as stewards of the environment. It was clear that we could actually build the most environmentally sound building, skyscraper, in the world.
The bank gave Richard Cook the opportunity he was looking for. Cook's vision, One Bryant Park, will combine multiple cutting-edge methods to save energy and resources. First, ventilation. A state-of-the-art system will take in air, clean it, circulate it through the tower, then expel it back out into the city. Next, recycled water. An advanced reclamation system will collect all rainwater that falls onto its roofs, storing it in large gray water tanks. The rainfall will be reused throughout the tower to help supply water systems for the skyscraper. Then, glass. A new crystalline facade will help keep the heat out, lowering dependence on interior lighting and air conditioning, saving on electricity. Cook's first challenge? Coming up with the initial design.
As an architect, you start with the blank canvas. It's what should this building look like? We're really interested in the pursuit of the perfect form, whatever it might be, at this location, at this place. So this board that we're looking at here are a whole series of sketches of ideas. And when I look at this, I can see pieces of the building that exist in its final form.
Building his vision is not an easy task. Not only is Cook raising the tallest energy-efficient building in New York, he has to build it in one of the toughest places in the world, Midtown Manhattan. Erecting a skyscraper in New York City creates extraordinary challenges, especially at the corner of 42nd Street and 6th Avenue, one of the busiest intersections in the city. To start off, the crews must dig one of the deepest foundations in Midtown.
This is an incredible deep foundation. It's the full width of the site, so 200 feet long, 450 feet wide, and it's about 100 feet deep.
Over 198,000 cubic meters of earth had to be removed from the site. But the team faced a big problem. Blasting in Manhattan is forbidden.
Typically blasting is the most efficient, quickest way to get through all that rock, but we have subway tunnels on 42nd Street and another subway line coming up and down 6th Avenue, which are right there and right there. And we can't really blast adjacent to that. There's also historic buildings all around the area, as well as a 50-story tower directly adjacent to us. Not really conducive to blasting.
So they had to do it the old-fashioned way, by digging.
You can't dynamite Manhattan, so it's all chiseled and machined out with large excavating machines.
All told, it took almost a year of excavation. By July 2005, the foundation was finally complete. Almost 2 years later, the building stands 48 stories high. That's over 200 meters above the streets. With 7 floors left to go, they're almost at the top. And work continues furiously. Today, they must lift almost 36 tons of material into the tower. With the help of a crane that sits almost 228 meters above the street. At the foot of the skyscraper, foremen prepare the loads. The crane operator is so high up, he can't see the loads hundreds of meters below. At these heights, the operator must lift each load blind, relying solely on the voices of his crew.
Got 25 to my hand. Keep coming up, 3, 2, 1. And coming into it.
The crane's biggest job is lifting the enormous steel beams to ironworkers that continue to build the floors of the tower. But first, the crew must get them here. The beams arrive on large flatbed trucks.
This is just an average load. This is about 23 ton, in that range, give or take a couple hundred pounds.
But getting a truck like this through the city traffic can be a nightmare.
We come in like 5 in the morning for traffic reasons. Mike will call us and say, all right, come on up. So then we start coming up. But that's the biggest nightmare is getting here.
By midday, the traffic gets worse.
I need a long distance to make a turn now. Like there's no way I can make one of these turns down these streets. I'm gonna have to go down and cut over 3 lanes to make a left-hand turn down there. There's no room to park on these streets, so that's the issue.
Once the steel arrives, the men work quickly, raising about 20 tons of steel to the 48th floor. Although these look like average steel beams, they're actually a secret weapon in this building's green arsenal. To be one of the most environmentally efficient skyscrapers in the world, One Bryant Park will embody state-of-the-art green systems from surface to core. Architect Richard Cook's conception is about changing how commercial buildings are constructed.
The fundamental breakthrough wasn't to design a building and then see how green you can make it, but it was in the DNA of the project. It was, how do we fundamentally rethink the way we build a building?
Cook's team decreed that many of the materials used to build One Bryant Park must be sourced within an 800-kilometer radius of the site, cutting transportation costs and energy use. What's more, the most basic building materials of the tower are largely recycled. It's one way Cook's team saves energy on the building from the ground up. All of the steel used to build the skyscraper is at least 60% recycled materials. Every steel beam going into the building started here. This plant collects scrap metal. Then, steel workers melt it down, remove impurities, and adjust its chemistry.
Our steel, first of all, starts with scrap metal. We recycle scrap metal. Almost 95% of our raw material is nothing but recycled scrap metal. That's your old cars, old washing machines, old dishwashers. We shred it, we compact it, we sort it, and that becomes our basic starting point.
This molten liquid runs through the molds and transforms into steel beams. Then, machines roll them out onto cooling beds, most still glowing from the heat. Once cool, workers test them for strength and durability. From this steel mill, each beam eventually makes its journey to the One Bryant Park site in Manhattan. But steel is not the only sustainable element that leaves this plant. Even the waste of the steel mill helps create sustainable materials. Steel mills produce blast furnace slag, a waste byproduct of steel production that is usually just thrown away. But for the One Bryant Park site, this slag waste is reused. It's a key element of the building's concrete, making up 45% of the mix. This leads to a drop in the carbon emissions created during concrete production.
When we work at scale, when it's an enormous building, little changes make big differences. Change from regular cement to blast furnace slag save 56,000 tons of CO2 production. So the concept is work at a really big scale, make little changes, you make big difference.
All told, 52,000 cubic meters of this concrete slag mix will fortify the superstructure. Not only does the production of concrete slag emit less carbon, it also makes the concrete stronger. Building with green materials is challenging in itself, but the teams at One Bryant Park must also face all the construction hurdles of any new skyscraper, like the unforeseen forces of nature. At the site, the skies open. A torrential downpour, which would one day fuel the building's water reclamation system, now forces most of the construction to a screeching halt.
Between the driving rain, the wet decks, it's made it difficult to get people up here in a safe environment for them to continue the steel erection. All the steel erection and the perimeter work is done for the day.
But not everyone is deterred by the rain. To keep on schedule, work must continue. The team braves the elements, pouring concrete floors even in the downpour. Surprisingly, the rain doesn't affect the concrete's strength. The men must keep pace with the steel erection to finish the building on time. As the building rises, so does the pace of the concrete team. The next day, the sky's clear. And just in time. Today's schedule, lifting one of the building's largest beams to the rooftop. And now the problem isn't rain. It's the wind. Weighing in at a whopping 9,000 kilograms, this behemoth must go up 268 meters. It will act as a support beam for the spire that will be set on the roof. The crew takes extreme precautions, strapping the beam to the crane. They want to avoid any catastrophic damage. Since cranes cannot control their loads laterally, winds pose a real hazard. And today, the winds ceaselessly shift. The team is eager to move, but for now, they wait. The men take every precaution because working on a construction site can be deadly. Crane accidents alone have claimed an average of 82 lives in the past 10 years in the United States. In November 2006, an entire crane collapsed in Seattle, killing one man and damaging 3 neighboring buildings. 8 months earlier, a crane worker plunged to his death in Miami after the safety platform on which he was standing damaged a crane brace. The list goes on. So with this beam, the men will take no risks.
We're going to send the load back today because, as you can see, it's too windy. We're almost 800 feet in the air, and you can see it's too windy. And picking it, they're worried that the load will spin into the crane. So we'll try it again in the morning.
But they must complete the 52nd floor of the superstructure. It's easier said than done. The crews work over 243 meters off the ground. Each man must climb 2 12-meter ladders and walk a maze of steel beams to get into position. To work at such heights, the men must have nerves as strong as the beams on which they walk. It's a high-wire balancing act with no safety net. As the cranes swing the steel beams over them, the men must carefully position each beam, locking it together like a jigsaw puzzle. It's a careful balancing act, but the men are undaunted. Today, they succeed. With the final beam, they complete the 52nd floor of the tower. Each day, floor by floor, these men bring the superstructure one step closer to the spire installation. They must get this building to its full height at 54 stories before the spire can be completed. The building continues to rise skyward, as many skyscrapers have before it, but its unique green features set it apart. However, this tower is not the first green skyscraper ever built. The team learns from techniques used by other architects and engineers.
We evolve and make buildings better and better and better. So there's an evolutionary process. We could not do this if others hadn't been before us.
A key green feature in this building is its use of natural air and green spaces. They want to use it in a new way, based on concepts used by other green skyscrapers. One of the first skyscrapers to use natural airflow in its design is the Commerzbank Tower in Frankfurt, Germany. Built in 1997, it's the third tallest building in Europe. Its use of natural winds and green spaces influenced the green skyscrapers that followed, including One Bryant Park. The Commerzbank's use of natural airflow makes this tower more energy efficient. A central atrium runs up from the lobby, 190 meters to the top of the building. Without a roof to top it off, this shaft acts as a natural ventilator. Winds blow upward through the offices to the people inside. This design created a complex construction challenge. The atrium forced the core support of the building, which is traditionally in the center of the structure, to the outer perimeter. The design keeps the building cooler. The Commerzbank Tower also uses 9 sky gardens, patches of green life that help cool the structure, taking in carbon dioxide and emitting more oxygen.
On one hand, it's the social benefit. Yeah, the gardens are also a place to meet. Somewhere they're the lungs of the building, but on the other hand, they're the social center of it all.
The building is 80% naturally ventilated, saving 30% on energy use.
If you do not have to switch on a machine, that's the most efficient machine. So if you do not need air conditioning, and you can design a building in a way that you don't need this incredibly energy-intensive machine running, that is a major breakthrough.
Richard Cook and his team took these concepts of natural airflow and green spaces a step further. At One Bryant Park, air enters the building at the top floors, then passes it through a giant air filtration system. The skyscraper will not only clean air for itself, it will also clean air for outside areas immediately around it.
And we filter out 95% of the particulate. We supply it to everyone, and when it exits the building, it will be cleaner than when it came in. So you could think of this block of Manhattan operating as a giant air filter for this part of the city as the air exits back out into the city.
Cook also wants to use green roofs at One Bryant Park, just as he's done at his own offices.
In our cities, what happens, there's something called a heat island effect. This roof was 170 degrees last August, hot, bubbling tar beach. And by planting these bags, we radically reduce the temperature of our roof, lowering our own little piece of New York City, lowering its temperature.
The green roof at One Bryant Park will not only keep the roof cooler, it will also serve as one of the collection points for rainwater. Cook and his team want to reuse every drop of rain that hits the building's roof.
We're standing right now, we're standing on top of the 6th floor roof. This is one of the main roof surfaces where we're collecting water. And basically this entire area is going to be covered in a green roof.
When rain hits this roof, it's absorbed by the plants. The excess funnels down into the building. There will be 4 tanks placed on different floors throughout the skyscraper, and 1 in the cellar. This gray water system captures and reuses almost all rainwater and most wastewater, saving over 400 million liters per year, which translates into an annual savings of about $500,000. For Cook's system to be operational, the crew must first get this tank into place. It is the fourth of 5 tanks that need to be installed. Today, the men must lift this 32,000-liter tank into place from the street level to the 41st floor above. It's bulky and weighs 9,000 kilograms. So getting it into the building is a formidable task. It's another risky operation for the crew. The straps must hold until the tank reaches its destination, over 122 meters above the streets. Up on the 41st floor, the men guide the giant tank from the crane onto the building. But its large size makes that difficult. The men must resort to using basic tools like chains and rope to do the job. Once in place, the gray water storage tanks will hold almost 260,000 liters of water combined. Deep in the building's cellar, Cook's team has installed a unique system that chills water by night to efficiently cool the building by day. 24 meters below the street surface sits the largest collection of cooling tanks in the city. 44 in all. These 7,570-liter tanks freeze 227,000 kilograms of ice each night. By day, this ice helps keep the building cool by feeding the air conditioning system for the entire skyscraper, ensuring that it all stays energy efficient and cost effective. The goal of the One Bryant Park Tower is to reduce energy consumption from the grid by half that of a building of comparable size. But it's an uphill battle because the city keeps getting hotter. Traditional skyscrapers not only use a lot of energy, they also radiate heat into the air.
Urban scientists sometimes use a term called the urban canyons, which is a kind of a version of a natural canyon, although it's man-made. Mostly they add to the heat effect. A couple of the ways is they increase the surface area in a city that's exposed to sunlight. So we have many more times just the area of Manhattan is exposed to sunlight than just the surface area of the island.
The Empire State Building's facade is primarily made of 5,663 cubic meters of limestone and granite. The sheer size of the building also helps to heat up the city.
The Empire State Building, I think I once estimated, has about 40 times the surface area of the block it sits on. And that extra surface area is available to absorb sunlight in the morning, during the day, and in the afternoon. And this is a very real effect in terms of cities absorbing more sunlight and causing them to have higher temperatures.
On this 29.5 degrees Celsius day, infrared photography shows surface areas on the Empire State Building, highlighted in dark red, that radiate heat over 38 degrees Celsius.
Just about everything we do tends to add heat to our cities. We're not going to remove buildings. Now, this is a really tough problem. Are we going to be able to avert, these high levels?
In the past, most buildings have not been designed to address global warming. But that's about to change. Now, a few architects are designing buildings with glass facades that operate more efficiently. Cook wants One Bryant Park's facade to keep interiors cooler. And one of its predecessors does much the same with its modern tower. Key to its efficiency is its use of glass and steel. One of the most distinctive facades in New York stands on 8th Avenue between 56th and 57th Street. At the Hearst Tower, a traditional 86-year-old facade meets the cutting edge in ultra-modern design. Not only is it modern, It's also one of the greenest skyscrapers in existence. The Hearst Tower uses state-of-the-art window technology in its glass facade. Its special glass coating lets visible light through while keeping heat out. Interiors stay cooler and demand less energy for air conditioning. In addition, the glass face allows more natural light to enter office spaces, reducing the need for artificial light and electricity. This facade structure also requires 20% less steel. The new tower's face boasts a unique diagrid design. Each diagrid section spans 4 stories, and each of the triangles carry the gravity load while also providing lateral strength, so beams don't need additional bracing. In the end, this saves over 1,800 tons of steel compared to a traditional structure of the same size. But building it was a challenge.
This particular job, there were no vertical columns. All the columns were diagonals, and they were actually not 2 stories long, they were 4 stories long. So we had to figure out how we were going to erect these columns. How do you stand up a column and have it physically stand there without bracing it or support it temporarily until you could tie the other column in?
It's all worth it in the end. With its cooling systems and decreased use of artificial light, the building consumes 26% less energy than a skyscraper of comparable size. Now, One Bryant Park is set to outdo that. Richard Cook wants his skyscraper to save 50% on energy use. As in the Hearst Tower, Cook wants to save energy at One Bryant Park by using a state-of-the-art glass window facade. Its special coating allows light to enter while blocking out heat. And engineers took it a step further.
We need to find another way to reduce the amount of sun energy that's entering into the building. So at the tops and at the bottoms of each piece of glass, we have this thing called a frit pattern, which is baked right into the glass. It's essentially paint that's baked into the glass. And it's a series of dots that fade from bottom up and from the top down. If we look right here, we can see these dots on the glass. That's the ceramic frit.
The dots are so small, they're hardly visible, but they reflect out the harmful effects of the sun, minimizing heat entry into the building. This keeps building interiors cooler, therefore, less energy is needed for air conditioning. But in order for this facade to be successful, this glass curtain wall must first withstand tough conditions. Windows on other modern skyscrapers have made headlines before, sometimes for the wrong reasons. In 1999, windows from a skyscraper in Chicago came crashing down, taking the life of a young mother. During the construction of the Hancock Tower in Boston in the early 70s, a violent storm blew out at least 63 glass panels, sending them shattering to the streets below. To avoid any catastrophes at One Bryant Park, the facade design is rigorously tested before it's installed. At this facility in Miami, Richard Cimbello and his team test equivalent glass facades under extreme conditions. They test the aluminum and glass curtain wall system with high-force winds and rains. The water rack provides the equivalent of 20 centimeters per hour rainfall. And this turboprop jet engine creates an 80 kilometer per hour wind force.
We're inspecting the wall for leakage. We will look along the gaskets, down the gaskets, at the corners. The wind gusts are also moving the glass in and out, somewhere around 1/4 of an inch.
The approved wall system design is then manufactured and installed at One Bryant Park. It will take over 8,600 glass panels to sheathe the building. Each section stands between 4.5 and 6 meters high and weighs about 453 kilograms. The men must lock each and every panel in place, one by one. To do that at these heights is time-consuming and dangerous. Here on the 38th floor, the men hang out over the ledge of the building, about 183 meters off the ground. The crews must race to keep up with the ever-rising steel structure.
There's 2 people on the bottom that hoist the panels out. The 3 on the top set the panel on the top and set it to the height and the correct in and out in the rack. It takes approximately 1 week to do the floor. Depending on the weather, the floor conditions, about a week.
To stay on schedule, they must complete the windows of this floor today. Just as in any skyscraper construction, time is money, and there is a constant pressure on the team to raise the structure on schedule. But in a green building like this one, there is even more at stake. Building sustainable skyscrapers costs about 5% more than a conventional structure. At One Bryant Park, that translates into roughly $60 million. For many companies, these additional costs may be the biggest stumbling block against going green.
Right now, a lot of these technologies are expensive, they're novel, and they're not really cost-effective yet.
But Cook thinks looking only at the initial costs is short-sighted.
If we save energy, ultimately in the long run, they will save vast quantities of money. The building will radically reduce the energy that it would have used if it was a conventional building. About half, about $4 million a year in today's dollars.
People are going to be forced to think about sustainable design more seriously, whether or not they want to, because they're going to be forced by their pocketbooks. The price of electricity is forcing people to be much more environmentally sensitive.
This is where business interests and environmental conscience converge. And when a commercial bank decides to go green, perhaps others will follow.
In the short term, it is true that there were some additional costs associated with the building of this building. However, from an energy use perspective, from the health of our employees' perspective, from the perspective of long-term play, this is a home run.
Back on the 38th floor, the window installation is almost complete. The men hang precariously over the edge of the structure, pulling together the final panels of this floor. As the windows continue to rise up the skyscraper at breakneck speed, the steel structure will soon stand at its full height. It's July 2007, almost 3 years after the skyscraper broke ground. And the men prepare for a monumental occasion. They're about to lift the final beam that will complete the top floor of the superstructure.
I'll tell you, it's a great project to be on. We're very proud to be here. And, you know, these buildings, they get prettier and prettier as they go up, and we're just very proud to be on this site.
They leave their signatures as a permanent mark on the superstructure.
Proud that we built this building.
The final beam reaches the top floor. But the work is not over yet. Now, with the floors of the superstructure at its full height of 288 meters, the men move into their next big challenge, setting a 78-meter spire on top of the giant steel structure. After weeks of waiting, the time has come. But just as the men are beginning the spire installation, something goes terribly wrong.
A bucket fell about 53 stories off a crane in Midtown, breaking several windows of the Bank of America tower under construction.
A container has crashed into the building, smashing windows and sending glass shards and materials hurtling down almost 245 meters to the streets below.
I heard this loud noise and we saw all this stuff falling down.
It fell down and hit part of the building, took the part of the building with it, and some of the debris may have come out and actually hit the windows of the building.
Since the shattered windows are adjacent to the crane struts, emergency crews are sent up to determine if the crane is still structurally sound and to clear broken glass out of the damaged window frames. Four pedestrians and 4 workers are injured. The accident shuts down a 2-block radius around the site. All construction comes to a complete stop, and the team must regroup. It takes nearly 2 weeks to address all the safety concerns. Then finally, the men move on to the last big job at hand. Topping off the One Bryant Park skyscraper. The crews must raise a giant spire atop the steel frame. Only then will the main structure of the building truly stand at its apex of 365 meters. The spire is so large, it must be transported in pieces on several trailer trucks, and massive loads going into Manhattan need special care.
Going into New York City, you basically lose 2 days because you have to roll in at night, and then first thing in the morning they'll have you go to the job site and offload. It is true what they say, this is a city that never sleeps, and there's always traffic out there to deal with. It gets a little hairy at times, you know, but you have an escort behind you and he kind of blocks it off a little bit. Even though New York is a really big city, the streets aren't the biggest.
Early the next morning, the spire pieces finally arrive at the site.
We'll definitely get it up there. I don't know if they're going to set it or not, but they will get it up. They have to, because there's nowhere to sit on the street.
The spire is made up of 70 individual steel pieces. Each must be lifted to the rooftop, where they are assembled and attached to one another. The process is expected to take nearly 5 weeks under ideal weather conditions. Despite the fog, the men get to work. The crane lifts a 7.5 meter long, at least 1.5 ton section into position. At almost 275 meters in the air, a slight miscalculation can prove fatal. Iron workers carefully guide it into place. Then weld and bolt the sections together. The operation goes off without a hitch. Over the next few weeks, the spire continues to go up section by section. In the end, One Bryant Park Tower will stand tall, 365 meters high. When it is fully operational, the tower will be one of the greenest in the world. And it may be leading the way into our urban future. The building is expected to reduce both energy and water consumption by 50%, and its occupants will benefit as well.
They will have a healthier environment. They will have clean air to breathe. They will be in an environment that they can feel not only proud about, but we will be giving them a better physical environment to be in. And this is a good blueprint for the future.
But with the high cost of building green and with global temperatures rising, can One Bryant Park make an impact?
By itself, usually one building won't make a difference. We've got to really get this widespread, because Manhattan Island's a small island, but we really have to transform huge numbers of surfaces and systems and technologies in order to make a dent in the climate.
Some believe the momentum has already begun to shift, and the trend may be contagious.
Many of the ideas in One Bryant Park are finding their way into other buildings already. And in another few years, we'll see lots and lots of things like it.
I don't think there's any question but that we're at a tipping point. Maybe we've crossed it. We're already over the line. The goal was to create the greenest building we possibly could. So people are watching carefully, like, gee, how did the Bank of America decide to spend the money to do a seriously green building? And in that small way, I hope that the building will be a trigger for lots of other projects around the country and around the world.
But Cook's vision at One Bryant Park is among the first steps towards significant change. Green architecture in skyscrapers is constantly evolving. It's not an easy process, but it's a vitally important one for the growth of our cities and the future of our planet. So as far as green buildings go, it seems, at least for now, the sky's the limit.